All right, let's go over this review. We're going to do it in parts. So let's get started. So our first part is just some basic information about the standard normal model. And we know that when we standardize it, it is centered at 0 with a standard deviation of 1, and that there's this 100% of data under the curve. Now, so what would a z-score of 1.2 mean? So if you got a test score that was 1.2, a z-score of 1.2, you got a test score that was 1.2 standard deviations above the average test score. So whatever that average ends up being, you were 1.2 standard deviations above that score. And then if you had a z-score of negative 1.2, then your test score was 1.2 standard deviations. So you were down here below whatever that average test score was. Now, we had talked about this at an earlier unit, but variance is just the standard deviation squared. So just kind of keeping that vocabulary in there. Variance is the same thing as your standard deviation squared. Now, let's go on here to this number 7. We were comparing 3 different batters, and baseball and many sports evolve over the course of the sport. And so then the statistics that fall from that, and like for example, your batting average and that standard deviation with which that occurs really varies over time. So, in fact, see, you can see in the 40s they had, or in the 80s, see, pitching started getting a lot better. So in the 80s, they had a lower batting rate. Okay. So what we then to do to compare the batters from different decades, we had to compare them to the people of their time. So, you know, here we had Ty Cobb. So we had to compare this is his X value to he was in 1911. So we had to use the decade, the 1910s mean and standard deviation. So that's the mean and standard deviation we used for Ty Cobb's X value. So we did that for each of these players. For Ted Williams, he was in the 40s. So he had this X value, compared it to the 40s mean and standard deviation, and so on. So once we did that, you can see by comparing and seeing how they did respective to their decade, the players in their time frame, that Ted Williams had the best overall re- related highest compared to the average at his during his time. So Ted Williams is better compared to the other batters because Ted Williams' batting average is more standard deviations above the mean batting average of his particular decade than Ty Cobb and George Brett. All right. So next, this question was a little bit different. We were given the minimum and the maximum, and then we were asked what is an approximation for the standard deviation. Well, I did give you a hint. So see, all across from the min to the max, it was 126 inches wide. And you know that on the standard normal model, it is 6 standard deviations wide. So if it is 6 standard deviations wide for that 126 inches across, you can just divide by 6 and see that each one of these standard deviations is about 21 inches wide. And then you can use that same idea to find the mean, because you would know it would be smack dab in the middle. So I just averaged the min and the maximum by adding them and divide by 2. So the average is about 73. Now, then we go into some problems that were more typically like what we had been seeing. So we were given the mean. The standard deviation in this case was unknown. What would that standard deviation be if a web length or width of 80 inches was in the top 15%? See, 15% are more than 80 inches. 15% are more than 80 inches, so that's the top 15%. So therefore, that's how we get our z-score based on the lower 85%. Then we set up our z-score formula and solved for that standard deviation. We multiplied both sides by sigma. 1.04 sigma equals 20, and then I divided by 1.04. And now here we have another one where we are comparing these scores on two different tests that had completely different baselines. So you can see this test averaged 500. This test averaged 142. So we are in different vicinities of values. So how did Brandy do relative to her peers on these tests? So that means we need to find the z-score. So for her, the information on test A, she was 1.8 standard deviations above the mean, but on test B, 1.75 standard deviations. So not quite enough. So Brandy definitely did better on test A because her score was more standard deviations above the mean. All right. And we'll do this one more page here before we then pause and make a second video. So we just kind of cut this up into little pieces. So here we had a distribution here. This is also an old concept from last semester where we have this function and it's a transformation of 3x plus 5. So the idea of this problem was to show you how mean is affected by all those functions, properties, add, subtract, multiply, and divide. So we would take that mean, and it is affected by 3 times that plus 5, and you get your new mean. But that standard deviation is not affected by adding 5. That standard deviation of 4, that standard deviation of a value of 4 is only affected by multiplication stretching. So 3 times 4. So the new standard deviation is 12. All right, this number 13, very similar to that problem that we had number 8 a few minutes ago where you had the minimum and the maximum. So that was a spread of 36, which is 6 standard deviations wide. So if you took that spread of 36 and divided it by 6, then you're dealing with a standard deviation of 6 inches. And then this was also changing units from inches into feet. So you were going to divide by 12 inches. So the new mean, you divided by 12 inches, and the new standard deviation, you also divided by 12 inches. And the last one on this video that I'll do is these two different distributions, and I have a picture here. We have population 1 and population 2. You can see population 1 is definitely more varied than population 2. Now, they're centered at the same location, but they have different standard deviations. Now, the question is, what percentage of observations falls within 2 standard deviations of the mean? So that answer is whether you are a skinnier variability or a wider variability, you are within 2 standard deviations if you have that middle 95% of data. So both of them within 2 standard deviations has 95% of the data. It's just in a more smaller area for population 2 than it is for population 1. All right, so there's the end of that first video, and I will make the next one for you here in just a minute. You can go on to the next video to see the rest of your review.